The idea that 90 degrees equals that many radians. So it's another way to write the angles.
But what is a radian?
A radian is the arc length
Okay.
in relation, but it's in relation to a unit circle, so a circle with a radius of 1. So what I was saying is circumference is 2 pi r. So if you make the radius 1, that means the circumference for a circle with radius 1 is 2 pi, right? Because 2 pi times 1 is 2 pi. So that means that if I go all the way around, the radian measure would be 2 pi. Which, what it does is using this measure for our angles instead of degrees, when we do problems using finding the length of the arc and like the area of this part, it just simplifies the formulas. Like the whole idea, the whole idea with this stuff, you've never done before, is just radian measure is just a different way to write angle measures. And when we start working with angular speed and arc length, area of sectors, all it does is it simplifies the formulas down. Okay? So the first part of this is simply working on changing degree measure to radian measure. And like, it's all going to be in relation to the idea that, like I said, all the way around the circle is 360 degrees, and it's also 2 pi radians. So converting from one to the other goes into that whole idea that you understand that 360 degrees is 2 pi. This one right here, which is 180 degrees, 180 degrees equals 1 pi radian. And this is going to be the one you actually will use for the conversion. So, okay? So, for the radian, just do write it out in words so you don't necessarily have to look at it just in pictures. All right, so 180 degrees is half a circle. In terms of radians, right, it's pi radians. So you kind of have to get those equivalent to each other. Yeah?
So 360 degrees equals 2 pi radians?
Yeah.
Cool.
Okay? All right? Now, for conversion purposes, all right, these two right here would benefit you. It's not necessary to write them out. As long as you remember the idea that 180 degrees equals pi radians, you can pretty much do the conversions without writing those things out. But the 180 over pi and the pi over 180 are going to be kind of the factors you multiply by. So if I ask you to do degrees to radians, you'd be multiplying by this. So it's every degree you go this far in terms of radians. So you go, that's how long your arc is in terms of like, the circle of 1. And then if I ask you to do degrees to radians, like convert it back, radians to degrees, you would be doing this. Okay, so the first set of problems you'll be working through will be simply doing the conversion. All right, if you've done before, it should be fairly quick. Okay, so we'll do those three. All right, so here's the thing. So you understand, I'm taking degrees, and I'm saying I want you to tell me the radian equivalent to these degree measures. Okay? Again, talking about, if I'm looking at 60 degrees, right, in terms of the circle, 60 degrees would be about here. That would be 60 degrees. The radian measure would be how long, pretty much how long that arc is, with a radius of 1, because that's what radian measures are related to. All right, and since we already understand like 2 pi is the whole thing, pi is 180, you can do pretty quick conversion. All right, so if I want to convert, I'm just saying, look, take your 60 degrees, right, and multiply it by this one. You're taking it, multiplying it by pi over 180. So in essence, what you're doing is you're doing 60 divided by 180, and simplifying that down, reducing it, and throwing a pi over it. Okay? So this would become 60 over 180, with 6 over 18 is 1 over 3, right?
Yep.
This is pi over 3 radians. So 60 degrees equals pi over 3 radians. They're basically equivalent. And depending on what kind of problem we'll work on, will depend on if we want to be a radian measure or degree measure. Louis.
This is going to be
Yeah, I don't know. When we get done, I'll put it.
Go Bulldogs. Why are you using like 180 instead of 360?
Because if I do 360, I'll have a 2 pi there, and I'm already going to have to reduce that. Because I'm going to reduce them anyway. So if I start with that, that already reduces the pi over 180. I'm trying to use the smallest possible number. You can do the other ones, doesn't matter. It's just bigger numbers to do. All right, so again, the whole process would be, right? So if I did the 110 degrees, it's 110 basically divided by 180. And then you just throw the pies in. So 180 over, or 110 over 180, 11 over 18 pi. This one converts to that one's there. And then the 285, you need 285 pi over 180. And then you would reduce as much as you can. What's that reduced to? I had it. Come on, you gotta grab the calculator. What is it?
19 over 12.
19 over 12? Great. Okay. All right, so converting from this one, guys, if you just want to make a note, this is probably the factor used from degrees to radians. All right, when you do it the other way around, this is the one you're going to do the work. So if I now took this and I just said, what?
What was that?
19 pi over 12?
No, it's the one before it.
11 pi over 18.
11 pi.
Because the zeros crossed out. All right, so if I switched it now and I did from radians up to degrees, now I'd be using this one because it said for every 1 radian, there's 180 degrees divided by pi, like that's the equivalent. 180 over pi degrees is equivalent to 1 radian. All right, so it means when I set these up, I'm just going to take, like if I do the pi over 4 one, I'm going to do pi over 4, and that's just multiplied by 180 over pi, okay? And to kind of keep you organized, radians, guys, they're not always going to have pi in them, but you got to think of it as radian measure sometimes says pi, so you're trying to multiply by the factor that cancels the pi out, right? Because pi and pi go away. So you're just left with 180 over 4, which is 45 degrees. All right? So again, do the 5 pi over 8. The 5 pi over 8, right, multiply by 180 over pi. Go away. Right? 5 times 180 is 900. Right?
This isn't too
900 over 8, what is that? What is it? 112.5. 5 degrees. And the last one I want to do is that. Okay, so 11 pi over 7 times 180 over pi. Again, pi's crossed out. You just got 180 times 11 divided by 7, which, what is it? 32.8. 8 or 9?
Oh.
Is that all?
No, it's died out. So I can, yeah, 32.9.
I got happy. So I actually understood it.
Okay, next thing. Now, this part here, we kind of already dealt with in terms of dealing with unit circle. Most of this beginning stuff we've kind of already dealt with. We just didn't state it like explicitly in there. Some of the times in the book or in the problems are going to ask you to kind of relate back to standard position of an angle. What they mean by that is you're looking at an angle where one of the sides is going to be on the positive x-axis, which, if you remember, like with the unit circle, we kind of already dealt with this right? Because our unit circle, we had like 0 here and 2 pi there, right? And when we talked about rotating around angles, we rotated this direction. And the reason you do that is because that gives you the standard position of the angle. Our one side of the angle was always right here. So like when we did an angle that was pi over 2, I mean essentially what it was this angle. It was this one side is on the positive x-axis, the other side, the terminal side, was right there. So when they say, right, that, you know, when they talk about standard position of an angle, all they're talking about is one side of the angle being this x-axis. And when they give you the number of degrees, it's just telling you how far to rotate around from that starting point. Okay, now, if you look at it, the 3 that are up there, they all have the same terminal side. This is one side where that rotation would stop would be the terminal side. Okay? If that happens, and I'll write this out, I'll have this on another slide also. If that happens, if they all have the same ending point, like 30 degrees, 390, negative 330, so on. If they all have the same ending point, like they all end in the exact same standard position, then that means they are coterminal with each other. Okay? If you're dealing with degrees, coterminal angles should always be a separation of 360 degrees away, plus or minus. Okay? So like this essentially right here, 390, that is 360 plus 30, the original one. Okay? 30 is the lowest number, the least positive number for that standard position for that angle.
Wait, what?
Okay? We kind of dealt with this when we did things like find sine of 17 pi over 3. You kind of dealt with it there, and I just told you to subtract 2 pi. All right, and the reason was you were subtracting a complete circle. Okay, so coterminal angles, if you're dealing with degrees, will always be factors of 360 apart. Like 390. If I added another 360 to that, it would also end at the same spot. If I did another 360, it would rotate around to right there. Another 360 would rotate around right there. They would all end at the exact same point. Okay? Even if you go the other direction, right? Because negative means you're going clockwise instead of counterclockwise. Okay? This negative 330, that's the standard position one, which is 30 minus 360. Gives you that. I subtracted another 360 from it, we're taking it around to there. Another 360 around to there. Okay? Now, so coterminal again. If you're dealing with degrees, separation would be 360 degrees between each set of them. If you switched it to radians, to 2 pi. Okay? So like I know that pi over 3, all right, and 7 pi over 3 is a coterminal angle. Because there, between the two, there's a difference of pi, which is one complete circle. All right? So if you actually had it drawn out, right, pi over 3 would be like right there, right, the 60-degree line. This would be pi over 3. If I went an entire 2 pi around right there, that would be 7 pi over 3. If I went another one, the 13 pi over 3, that would also give me a number. Okay? The biggest thing I want you to get is understand, when they have this term, they just mean coterminal means angles that end at the same point. They're on the same kind of ray. All right? The one-sided. Because you never move, this side of the angle never moves. It's always stuck right there on the positive x-axis. So we're dealing with standard position. All right? We're not shifting anything around. Okay, so so this would kind of be an example of a problem you would have. And the reason it would give you one like this is it would say between 0 and 2 pi. Just to kind of say, I want the other way I can say this is I want the least positive coterminal angle with it. Okay? And all it's asking to do is kind of remember that this would be, if I see a pi in there, guys, I would understand that's radians. Coterminal angle with radians are always separated by a length of 2 pi. So what I'd be doing is I'd just go, 17 pi over 6. And again, we kind of did this already. Okay, I might not use the words like coterminal and stuff like that, but you kind of already did it. So 17 pi over 6 minus 2 pi is how much?
5 pi over
5 pi over 6. That's in between 0 and 2 pi. That would be the answer. If I asked you to just come up with another coterminal angle, you could have added 2 pi over 6 and also got an answer. But if I didn't specify between 0 and 2 pi, if I just said find another angle coterminal to it, I could have added 2 pi over there. All right, and got what, 29 pi over 6? And that also would have given me a coterminal angle. Okay? If I had done this in degrees instead of radians, you'd be subtracting and adding 3/6. Yeah.
I don't see that you got 5 pi over 6.
5, 6. 17 minus 12.
Oh, okay. Wouldn't that be 2 pi over 1 then?
Right. Okay, now, okay, there are 4 formulas you guys need to get. If you haven't seen it. There's going to be one for length of circular arc, area of circular sector. And all these guys are going to be in relation to dealing with radian measure. Okay, so when there's a theta up there, it's like the angle in radian measure. At least for the most part. Sometimes they'll switch maybe units on you, and you can still use the same formula. Just as long as you keep units consistent with what the problem is. But usually when you do these, you'll be dealing with radian. Okay, so length of circular arc. All right, so the way this one looks is it goes S equals R. Like I said, when you did this in geometry, right, you would have had to do a proportion with it. And guys, S is arc length. That's what it represents. So the S in this formula is arc length. R is radius. Okay, and theta is just the angle. So like this right here would be asking you, they go, there's theta, there's R, this would be your S. All right, from there to there.
What did you call that circle thing?
Theta. All right, area, guys. This is 1/2 r squared theta. Okay, again, if we did this in geometry, it would have been done with proportions, like pi squares in there and so on. But if you have this already converted to radians, you don't need to worry about it. Okay, and again, this would mean that you're looking at R's there, theta's there. If theta's there, that means this is the area you're trying to find. Let me write these up. Angular speed, this is,
Okay, we heard.
it's actually a, the W, guys, it's actually like a lowercase omega. It's W would be like this. It's kind of curved in on this side. Okay? And then the linear speed would be like this.
I really want to
All right, hey guys. Guys, hey. Doing 3 examples, please, okay? Only 3. All right, so let's do the first one. All right? Now, here's the thing with this. Like I said, with the length of an arc and the area of the sector one, those are all going to be in radians. So if I give you one like this where the angle that you're looking at, the theta, is in degrees, you need to switch it over to radians first before doing the problem. Okay? Because I mean, if it's in radians, then you can go ahead and use the formula that was just the S equals theta R, okay? Which the radius is fine, that doesn't have to change, okay? The only thing you gotta make sure you're doing is taking the 55 degrees and converting it to radians, right? So this would mean if I'm converting it to radians, I'd multiply it by the, right, pi over 180, correct? What is that? What's that reduced to?
11 pi over 36.
So this is 11 pi over 36 radians, okay? Then that's when you can just go ahead and plug them in. Because the arc length formula is simply you take this, multiply it by that, and that's it. All right, so this would become arc length is 11 pi over 36 times 10.
Wait, oh my god.
What?
Wait, no. What, I'm sorry, what did you do with the 55 and the pi over 180?
Took the degrees and converted it into radian measures. What you want to do first anyway if you're doing arc length and area.
Is that feels really confusing?
Yeah, the A got messed up. All right, so arc length would be right there. All right, now for the area, guys, since it's already in radian formula, that means you could go up there and do the area formula, r squared theta. Okay, so guys, area would be 10 squared pi over 36, which is, what is that multiplied to? 50 times 11.
I got it.
That's 550 over 36.
550 over 36.
If you can reduce these. I would like you to. All right. But if you left them that way, obviously I'm not going to take off because I didn't say you had to reduce these. Like if it doesn't say in the question, I really don't care if you do or not. The biggest thing is if you're doing right now, if you're doing length of an arc or area of a sector, first thing you got to do is just convert to radians part. Because once it's converted to radians, you just put the numbers in. Yeah, Ashley.
At the bottom it says 10 something squared. I don't know what it is.
Right here.
Not at the bottom. Oh,
The area is radius squared. 10 is the radius.
Oh.
Squared. And then that's this is the theta.
That's meters.
Oh.
No, I'm talking about like.
This right here is
where
meters.
the end of
Wait, how do you think
Value, whatever.
Oh, is that a French?
So it's
That's
in like.
angle equals theta. Theta is the angle. You just, when you do it, you wouldn't use 55.
Oh, yeah, I can do that.
Use the theta after you convert the radius. All right, that's one, guys. This one would be like more of the straightforward one. Okay. Now, the next one is, this is area of sector, okay? The angle they give you, right, the theta here, it's already in radians. It says 2 radians, all right? It's 2 radians. It's not like I forgot to put pi up there. I mean, it's just 2. And they give you the area. It's just saying find the radius. So that means, here's the thing. If they give you theta already in radians, that just leaves you like one last thing to do. I don't have to do the conversion first. And since it's already in radians, I'm simply going to use that formula to find out what I want, which is the radius. That means I'm plugging in what I know, right? Just like a regular formula. 16 goes there, right? That's the area. That's what they tell us to do. Okay? 1/2 r squared times 2. This 2 is the theta, right? Theta is 2 radians. So this actually becomes a fairly easy problem with it being 2 instead of 2 pi, because you'll get 2 times 1/2 just becoming 1. You get r equals 4. Now, look, I will guarantee someone's going to think, if they give them a measure, because most of the time, you guys think radians, a pi has to be in there. And you'll see 2 radians, and you'll think you got to put a pi with it, okay? And you think they forgot it. They didn't. It could be any kind of measure. I can say 16 radians. It's still in radian measure. All right. So if the pi isn't there, it's not there on purpose. Okay.
What should we add next to the below?
Meter. Units. All right, now, last one. This is going to be one with the speed one. Okay, angular and linear speed. These problems? This is just fairly easy. Okay, so basically it's, so 2 parts.
Oh, no, not
Okay? Angular speed is the first one, then we'll do linear speed. Okay? So that means that for A, right, you're doing the angular speed, which is simply just the angle in radians, because it gives you units here, just to remind you, it's in radians, divided by the time. Okay? The time I've already got. Like RPMs means what? Rotations per minute. So here's the thing. I can make this very easy on myself and just do my time at 1 minute. Meaning, I don't have anything to divide by. I mean, if I keep it at 1 minute, it's going to be theta over 1. Which means if I find out what this is, I've got the angular speed of it. I don't have to divide by anything. Okay? You can make it whatever time you want. You would just have to convert everything else up to the correct measurement. Okay? But since 1 minute, like 1 minute equals 45 rotations, that means 1 minute, it goes in a circle 45 times. And how many radians are in one circle? 2 what? 2 pi. So that means for me to get theta here, all I got to do is, I'm doing 2 pi, right? That's 1 circle. And I know in that time frame I'm looking at, it's going around 45 times. So 90 pi would be what it is, because it's 1 circle, this is how many circles. And since we kept it at a time of 1 minute, like I said, that makes this easy. 90 over 1 is still 90. You just got to make sure at the end, you put the units there, so it becomes speed. So for part A, it's just that, 95 radians a minute. All right. If you have the opportunity to pick your time frame, pick a time frame that's easy to divide. You don't always have that, but if you do, it's easy to divide. Okay? So even when I do the next one, right, with the velocity one, right, or S over T, I'm still going to keep my time at 1 minute, so that all I need to do actually is find out what S is. I'm going to divide by 1, so whatever S is what my answer is going to be, with the proper units at the end. And to find the S, what was the formula for that? Theta R. Theta R, right? We've already got theta. Theta is 95. What's the radius?
32. Radius, I got 3.
Yeah, the radius is still 16.
1,445.
1445. All right, so I know the arc length. So that means like on the tip of the blade, after 45 rotations, it travels that many inches. So that means all I'm doing is 1440 divided by 1. That's that easy so that we actually have fairly easy division from.